What's going on, Alex Bros? It's Mr. C here, and what we're going to do in this example is what's called expanding a logarithm. Let's get started. So our expression that starts us out here is log base 4 of 16 x to the 6th. What I'd like to do is take a peek at what's going on inside that argument between 16 and x to the 6th. What's going on is a particular operation, and that operation is multiplication. Since we have multiplication going on inside the argument of a log, we're allowed to use the product rule or the product property, which tells us that multiplication breaks up into addition of two logs. So let's start out with log base 4 of blank added to another copy of log base 4 of blank. Now, from that video discussing the product, quotient, and power properties, we know that the first factor, which is 16, is going to go inside our first log, and the second factor, which is x to the 6th, is going to go inside our second log. So when you apply either of those three rules, you want to continue to ask yourself, okay, is there anything more that we can do this time, between the two logarithms? So what usually helps me is just asking myself, okay, well, do I see any more multiplication going on inside the argument of either of these logs? Do I see any division, or do I see any powers, etc., etc.? Let's take a closer look at this first log base 4 of 16. Notice that 16 actually happens to be a power of 4. In particular, 16 is 4 squared. So if we wanted to, we could write the argument of that first log as 4 squared. And by virtue of one of our inverse properties, the log base 4 notation will cancel that 4, and what would result from this after the dust settles is just an ordinary 2. All right, just an ordinary 2. It's not a power of 2. So that's how the first logarithm simplifies further. As for the second logarithm, it's pretty clear that we still have a power inside of the argument. In particular, a power of 6 that's on that x. By another property of logarithms, in particular the power property, what we're allowed to do is take this 6 and write it as a factor. In other words, we're going to take 6 and multiply it to that log base 4. All right, it only goes in front of the log that it's associated with. It would not go in front of that 2. All right, so cleaning this up, we'd have 2 plus 6 times log base 4 of x. And this is where the pain and torture, the fun and excitement for this problem ends, and I'll explain why. All right, obviously, there's nothing more that we can do with simplifying the number 2. It'll just stay as is. Now we do have 6 times log base 4 of x. So a couple of things I need to clarify here. First of all, log base 4 of x is in its simplest form. There's nothing going on anymore with regard to its argument. No multiplication, division, or powers. You might be wondering, though, if this is equal to 8 times log base 4 of x. I'll let you know right off the bat that it's not equal to 8 times log base 4 of x, because as an example, or maybe a quick recall, if we were to take 2 and add it to 6x, this would not equal 8x. 2 plus 6x is just 2 plus 6x. I mean, maybe you'd want to factor the 2 out. You don't have to, though. But in other words, we can't add 2 plus 6x to get 8x because 2 and 6x are unlike terms. All right, and the same is true here. All right, the number 2 and the term 6 log base 4 of x, They're not like terms, so we can't go any further with it. All right, so 2 plus 6 times log base 4 of x is our answer here. And that's where this video ends. I'll see you in the next one.